Hello everyone. Today we are going to discuss about pulse code modulation, the continuous of the previous session. Here one of the important parameter in pulse code modulation is transmission bandwidth. So transmission bandwidth is depends upon the number of quantization levels. We have already discussed in pulse code modulation the quantization levels is denoted as Q. It depends upon the number of bits, that is the formula quantization level q is equal to 2 power v. So v is the number of bits. For example, v is equal to 3 means your quantization level has q is equal to 8. Similarly, the number of samples per second, that is your frequency, is denoted as 1 divided by ts, that is ts means the sampling time period. So the sampling frequency is inversely proportional to the sampling time period. Therefore, the number of bits per second, how many bits we have transmitted in a channel per second, is equal to number of bits per sample and number of samples per second. That is your signaling rate. It is denoted as R is equal to the number of bits V into the sampling frequency fs, that is also denoted as bit rate, that is rb is equal to v into fs. Both the equations are same, where fs is equal to, it satisfies the Nyquist rate, that is fs should be greater than or equal to 2w. Here w is the cutoff frequency, or your normally we denote it as the message signal frequency. Fs greater than or equal to 2fm, or fs should be greater than or equal to 2w for this pulse code modulations. And from this signaling rate, we can easily derive the bandwidth of the pulse code modulations. That is bandwidth, it should be greater than or equal to the signaling rate divided by 2. We know the signaling rate R is equal to V into f of s. Substitute this V into f of s instead of R. We have this equation, bandwidth should be greater than or equal to 1 divided by 2 V into fs. We also know fs should be greater than or equal to 2w. Substitute again 2w instead of fs. We have the equation, bandwidth should be greater than or equal to vw. There are three formulas for finding the bandwidth in pulse code modulations. So from this bandwidth, we can easily conclude that whenever we have increased the number of bits, that is bandwidth depends upon the bits and sampling frequency. So the number of bits increased, the bandwidth also increased. So this is the conclusions. So this formula is very much useful to find the bandwidth, because I already told in the previous class, in the previous lecture, the bandwidth of the pulse code modulation is very large when compared to the analog modulation techniques, because the bandwidth depends upon the number of bits. Normally the bandwidth depends upon the sampling frequency. Here the number of bits is multiplied with the sampling frequency. Therefore the bandwidth is large when compared to the analog modulation techniques. So advantages and disadvantages in pulsium and PCM technique. Noise interference is very less, because it is a digital modulation techniques. There is no chance to add noise during the signal transmission. Then multiplexing is possible. Second one is multiplexing is possible, because we can multiply two or more signals easily. It is possible. And also encryption and decryption is possible, because in the transmitter side we have used the decoder, encoder, and the receiver side we have used the decoder. Similarly, it is possible for encryption and decryptions. So main disadvantages is complex when compared to the analog technical. It is little more complex, because so many steps we have followed to convert the analog signal into digital signal, because low pass filter is used, sampling circuit is used, quantization circuit is used, and encoder circuit is used to convert the analog signal into digital, so a little more complex when compared to the analog techniques. And second one is channel bandwidth is high when compared to analog signal, because it depends upon the quantization level. That quantization level depends upon the number of bits used for represent the quantized signal into a pulse coded signals. So this is what the important points for pulse code modulations. So I hope you understood better. The next video I will discuss some of the problems for even better understanding of PCM. Thank you.